Hi everyone, welcome to the final review session. So today we're gonna go over the practice final exams. If you have any questions, please feel free to unmute your microphone and ask me. Or you can type your questions in the chat. Okay? Alright, problem 1. We want to find the domain of the function. Write your answers using interval notation. So when we talk about the domain, there are 3 types of functions with special domain, right? So we have the square root of a, then we need the things inside the square root to be greater or equal to 0. And then we have the fractions. We need the things in the denominator, right? We need the denominator to be not 0. And then the third one, natural log. We need the things inside the natural log or any log functions, okay, to be positive. So these are the functions with restricted domain. Okay, other functions, you can imagine the domain is all real numbers, so minus infinity to infinity, like polynomial, exponential functions. Domain is minus infinity to infinity. Of course, for the trig functions, we have some functions like tangent, cotangent, and secant and cosecant. The domain is, well, they have a lot of vertical asymptotes. Okay, so that's why the domain is not all real numbers. Okay, but usually we just look at square roots, fractions, and natural log. Now, come to this problem. So you check. Oh, you see the first term? We see natural log. So we need the things inside the natural log, which is x plus 10. We need this to be positive. And then we solve for x. We can subtract 10 on both sides. And then we have x is bigger than negative 10. Okay, so this is for this one, this expression. And then, the second term. You see, the second term we have the square root. So for square roots, the things inside the square root, which is 21 minus 7x, we need this to be greater or equal to 0. We solve for x. We can add 7x on both sides. And then the left-hand side, we have 21 greater or equal to 7x. Some of you might ask, can we subtract 21? Yeah, you can subtract 21 on both sides. But then the next step, if you subtract 21, you get negative 7x greater or equal to negative 21. So when you solve for x, you divide it by a negative number. Well, then don't forget to flip the inequality. So you get negative 21 over negative 7, which is negative cancel. 21 over 7 is 3. See? And here, what you're doing, you divide it by 7. When you divide it by a positive number, it won't change the inequality. So you get 3 greater or equal to x. That's the same thing as saying x less than equal to 3, right? And you see, you have the same answer. So there are many different ways to solve inequality. Okay? Just make sure you check your process carefully. When you divide it by a negative number or multiply by a negative number, flip the inequality sign. Okay, and then let me erase these. Alright, what's left? Now we have the denominator. For denominator, we need the denominator cannot be 0. Well, a product of two factors is not 0. That means each of the factor cannot be 0. So you put and here. Okay? X minus 3 is not 0. and x plus 1 is not 0. We solve for x, so f3 on both sides. We get x not equal to 3, and x not equal to subtract 1 on both sides. Okay, so this is what we get. Then draw the real number line. X greater than -10. So -10 is here. Greater than means, oh, we don't include the endpoint. So we put open circle. If we want to include the endpoint, we put solid circle. So greater than is to the right of -10. And then next one, next condition. X less than or equal to 3. So 3 is right here, less than or equal to solid circle. And then it's to the left. Okay? And then you keep going. Next one. X not equal to 3. That means take out the point 3. Okay? So we take out the point 3. And then x not equal to -1. Take out the point -1. What's left? See, we have -10, not include the endpoint, so parentheses. And then keep going. -1, not include the endpoint, parentheses. Union, -1, not include the endpoint, parentheses. And then go up to 3, not include the endpoint, so parentheses. So this is our answer for problem 1. Okay, if you can understand problem 1, could you type 1 in the chat? Thank you. Then we keep going. Problem 2. Solve the following equations. Give both exact answer and approximations round to 3 decimal places. Okay, so here, wow, this is a quadratic equation. So what we do is expand it. Do you see the right hand side is not 0, it's -12. So when you solve quadratic equations, you want to move all the terms. So we want to move all the terms to the left hand side. And then you want to combine all the like terms. And then factor. Okay, either factor or use the quadratic formula to solve for x. Therefore here, we can expand it first. So expand it. 3x times x is 3x squared. 3x times 4 is 12x. -1 times x is -x. -1 times 4 is -4. So we expand it, multiply out. And then combine the like terms. 3x squared, 12x minus x is 11x. Minus 4 equals -12. We want to move all the terms to the left hand side, so we add 12 on both sides. So 3x squared plus 11x. 12 minus 4 is 8. You see? Here we combine all the like terms. This is the standard form of a quadratic equation, right? And let me also write it down. So standard form, ax squared plus bx plus c. Oh, sorry. I should call this is the general form. Yes, this is the general form. Because the standard form is the vertex form of the parabola. Okay, and then we solve for x. X is 2a negative b plus or minus square root of b squared minus 4ac. So you either use the quadratic formula or you can factor it. In this case, factor may be easier if you're familiar with factoring. So factors of 3x is 3x and x. Factors of 8, it could be 1, 8, 2, 4, okay, or 4, 2, and 8, 1, okay, and it could be also minus 1, minus 8, minus 2, minus 4, minus 4, minus 2, minus 8, minus 1. So you put different pair there. And let's plug in here. So you put 1 and 8. And then let's see what happens. Okay, so you get 1 times x is x. 3x times 8 is 24x. Then you know, okay, it must not be this one. See, x plus 24x is 25x, which is not 11x. So therefore, we don't pick the pair 1, 8. And then you keep going. How about the 2 and 4? So if you put 2 and 4 there, you get 3x times 4, 12x, and this is 2x. Do you see when we add them up, it's 14x? So 2, 4 does not work. Okay, so you keep going and try all the pair. And how about 4, 2? 4, 2 give us a 4x, and 2 times 3, 6x. You add them up, you get 10x, which is not 11x. So we know 4, 2 does not work. And so you keep going until you find a pair that works. See? 8 times x is 8x. 3x times 1 is 3x. You add them up, that is 11x. So this is our factorization. Okay. And yes, and because this is plus, that's why you try all the positive. If that sign is minus, then you try the negatives. Okay. Alright, let me erase all of these. So this is how we think. Then once we get the product of two factors equal to 0, we set each factor equal to 0. And we put OR to connect them. Okay. And solve for x. So subtract a on both sides. We get 3x equals negative 8. And then both sides divided by 3. So x equals negative 8 over 3. Here, subtract 1 on both sides. So we get x equals minus 1. So our solution, x is negative 8 over 3, or x equals minus 1. So this is part A. If you can understand part A, could you type A in the chat? Thank you. Great. Okay, problem part B. Okay, so this is equations involving rational expression. So the first thing we do is find the LCD, least common divisor. Oh, sorry, least common denominator. Yes, least common denominator. Right. Okay. In this case, you see the first term, the denominator is 3x minus 2. The second term, the denominator is x plus 1. The third term, denominator is 3x minus 2 times x plus 1. Therefore, the least common denominator is 3x minus 2 and x plus 1. Okay? And we know denominator, least common denominator cannot be 0. So therefore, you get 3x minus 2 is not 0. And x plus 1 is not 0. Solve for x. Okay? So here add 2 on both sides. 3x is not 2. So divided by 3, we get x not equal to 2/3. And then this one, subtract 1 on both sides. We get x not equal to -1. So these two numbers are the domain. Domain x cannot be those two numbers. Okay, and then we continue, right? So that was the first step. The second step, we multiply the least common denominator on both sides. Okay, so which means on one side you're gonna multiply the least common denominator for each term. Okay, so term is separated by plus or minus. Therefore, on the left hand side here we have 3 terms. All 3 terms, you need to multiply all 3 of them by the LCD. Okay, so yes, and do it for all the terms. So therefore, the first term, x over 3x minus 2, multiplied by the least common denominator, 3x minus 2, x plus 1. That's the first term. Second term, which is 4 over x plus 1, we multiply by the least common denominator. So 3x minus 2 and x plus 1. Plus the third term, 38 over 3x minus 2, x plus 1, and multiply by the LCD. Equals, you see on your right hand side is 0. You know 0 multiplied by anything is 0. Okay, well, yeah, 0 multiplied by everything is 0, right? Everything. So therefore, this is what we get for step 2. And then we can cancel. Okay, so we can cancel. What's left? Okay, look at the first term. We have x times x plus 1 left. Second term, we have 4 times 3x minus 2. And the third one, we have 38. Oh, that's it. 38 equals 0. Well, now this is a quadratic equation, right? So we expand it, distribute. X squared, x times 1 is x. 4 times 3, 12x. 4 times negative 2, negative 8, plus 38 equals 0. And then we combine the like terms, right? See, you can see the next step is similar to what we did before in the previous example. Okay, so we combine the like terms. We have x squared. X plus 12x is 13x. Minus 8 plus 38 is positive 30, equal to 0. And then factor it or use the quadratic formula. Factors of x squared, they are x and x. Factors of 30, 1 and 30, 2 and 15, 3 and 10, and then what? 5 and 6, etc. Okay, and then which one will give you 13? You figure out, oh, okay, after you try all of these, you realize 3 and 10, that will give you 10x, and 3 times x is 3x. You add them up, you get 13x. Okay? And then, okay, so now we have the product of two factors equals 0. So we set each factor equals 0. Okay, so x plus 3 is 0, or x plus 10 is 0. So solve for x. Subtract 3 on both sides. We get x is negative 3, or here, subtract 10 on both sides. we get x equals -10. Finally, you have to check, are these two numbers in the domain? See, x cannot be -1, x cannot be 2/3. And so -3 and -10, they are okay. Okay, so these are the solution. So this is part B. When you have fractions, you need to check whether the solution is in the domain. So for all the the special functions, like square roots, fractions, and log, after you find the solution, make sure you check whether they lies in the domain. All right. So if you can understand part B, could you type B in the chat? Thank you. Okay, so this is part C, not F. Okay, so this is a equation involving exponential expression, right? So what we do is notice that the base are different. On your left hand side, the base is 3. On the right hand side, the base is 2. So in this case, we apply ln on both sides. Apply natural log on both sides. So here on the left, ln 3 to the 5 minus 2x equals ln 2 to the 7x plus 1. Okay, and then use the ln property. What are the ln property? So ln, so if you have ln of p plus ln of q, we can combine them, we get product. If you have ln p minus ln q, we can combine them, we get fractions. And if you have ln p to the, let's say, a, then we can move the a down in front. Okay, so these are the properties of ln. Therefore, here we move the 5 minus 2x in front. But when you move it, don't forget the parentheses. Okay? Because without the parentheses, it'll be wrong. So parentheses, very important. Okay? So here you can write down the steps. So we can move the exponent in front of the ln, and don't forget the parentheses. Okay. And then we distribute. Okay, distribute. So 5 times ln of 3. Oops. Let me save it. Yes, 5 times ln. Why it does not allow me to draw? Let me do it again. Okay, 5 times ln 3, and then here minus 2x times ln 3. Okay, yeah, here you can put the parentheses, or you don't have to. Maybe we don't have to put the parentheses, but usually I like to put the x at the end. So let's switch the order, because then 2 and ln 3, they're like the coefficient of x. Okay, but then here you gotta put the parentheses. You don't want to have confusions. Is really ln of 3 times x, or is ln of 3x? Is the x inside the ln or outside the ln? You don't want to have confusions. So please put your parentheses. And then on the right hand side, 7x times ln of 2. Let's change the order. So it's 7 ln of 2 times x. And then 1 times ln of 2 is ln of 2. Okay, now we move all the terms with x on one hand side and move all the terms without x to the other side. Okay, so move all terms with x to one hand side and move all terms without x to the other side. Okay, so therefore here, because do you see this is negative? So if you want the coefficient of x to be positive, it's better to move this to the right. So that means we want to add 2 ln 3x on both sides. So then on the right hand side we have 7 ln of 2x plus 2 ln of 3x. Okay, and if you want to move the ln of 2 to the other side, well, you want to subtract ln of 2. So on the left hand side, we have 5 ln of 3 minus ln of 2. By the way, we cannot combine them. Just leave it like that. So you cannot do, oh, ln of 3 minus 2, so it's ln of 1. No, no such things. So just leave it like that. Don't try to combine them. Okay. So on your right hand side, see, we can factor the x. So we can factor the x, and then we can solve for x. So factor out the x with 7 ln 2 minus 2 ln 3. Here we don't need a parentheses because the x is already outside. And then left hand side, still 5 ln 3 minus ln 2. So x is your left hand side divided by this right hand side factor. Okay, so we ran out of space. Let's put it on the top. So 5 ln 3 minus ln 2 divided by 7 ln 2 minus, plus, not minus, plus 2 ln 3. So this is the exact answer. And then, did the problem ask you to find 3 decimal places? Yes. Well then, you gotta put this in your calculator, and let me see. So I plug into my calculator. I got 0.681. So please make sure when you plug in your calculator, you get 0.681. Okay, so that's 1 point of this problem. Okay, so if you can understand part C, please type C in the chat. Thank you. Okay, we keep going. Here, when we solve equation involving log, we want to combine them. So how do we combine the log? Well, use the property. Log combine the subtractions into fractions. So this is log 5, and then we have x plus 4 over 2x equals 3. Okay, so we combine. Addition will give us product, subtractions give us quotient. Okay, so now let's see. We want to get rid of the log 5, so both sides raised to the power of 5. So 5 log 5, and then x plus 4 over 2x is 5 cubed. 5 and log 5 cancel. So we have x plus 4 over 2x equals, so you know 5 times 5 is 25, times 5 is 125. Okay, and now we can solve for x. Both sides multiply by 2x to get rid of the denominator. And then 2 times 125 is 250. And then subtract x on both sides. We get 249x. Solve for x. So both sides divided by 249. We get x is 4 over 249. Okay? And because here the problem has log. When you have log, you need to check your work. Okay? So let's plug in the log expression. So log 5, x is 4 over 249. Right, everybody? We have, this is x plus 4. Okay, so you can see this thing inside is positive, so this is okay. The other expression, log 5, 2 times x. X is 4 over 249. And this is also positive, so okay. So this is the solution. If you plug in here, you get the things inside the log is negative, that means it's not okay. Then we have no solution. Okay? So this is part D. If you can understand part D, please type D in the chat. Okay, great. And then keep going. Problem 3. Write the standard form of the equation of the parabola that has the vertex 2, -3 and passes through -4 and 5. Okay. Here, what's the standard form of parabola? Sometimes we call this vertex form. So we have y equals a x minus h squared plus k. This is the vertex form. Right, everybody? And here, the vertex is h comma k. Therefore, here we know the vertex is 2, -3. So, oops. So h is like 2, k is like -3. Therefore, when you plug in the vertex form, y is a we don't know yet. h is 2. K is -3. Alright. And how do we find the a? Well, you use this information. The parabola passed through -4 and 5. That means you plug in x is -4 and you plug in y is 5. The equation is true. So y is 5, x is -4. So 5 equals a. -4 minus 2 is -6. Square is 36. Minus 3. Solve for a. Add 3 on both sides. A equals a times 36. So both sides divided by 36. Let's simplify. The common factor is 4. And so a is 2 over 9. Standard form. Y is, see, put it back. A is 2 over 9. X minus h is 2 minus 3. K is -3. So this is the standard form. Okay, if you can understand problem 3, could you type 3 in the chat? Okay, thank you. So keep going. Okay, this problem is a longer problem. Complete factorization of p of x. List all the zeros. Okay, so here we have, first of all, we do factors of the constant term. Here the constant term is -2. So factors of -2, we start with plus or minus 1, and then plus or minus 2. They're integer factors. And then we look at factors of the leading coefficients. Leading coefficients is 3. Factors of 3, plus or minus 1, plus or minus 3. And then possible roots. So we use these numbers divided by those numbers, right? So plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 2 over plus or minus 1 is plus or minus 2. And then plus or minus 1 over plus or minus 3 is plus or minus 1/3. Plus or minus 2 over plus or minus 3 is plus or minus 2/3. So these are all the possible roots. Now let's plug in. So look at the list. Try x equals 1. P of 1 is, see, you plug in our polynomial. We have 3. 1 cubed is 1. So 3 times 1 is 3. And then 11 times x squared. So x squared is 1 squared is also 1. So 11 times 1 is 11. Plus 9 times 1 is 9. Minus 2. Wow, we have a lot of positive numbers and very small negative number. Of course, this is not 0. And then we keep going. P of -1. Okay, so 3 -1 cubed plus 11 -1 squared plus 9 times -1 minus 2. -1 cubed is -1, so we have -3. -1 squared is 1, so we have 11. And then -9 minus 2. You see, -9 minus 2 is -11, so these cancel, we get -3, which is not 0. So we keep going. So 3 times 2 cubed plus 11 times 2 squared plus 9 times 2 minus 2. 2 cubed is 8. 3 times 8 is 24. 2 squared is 4 times 11 is 44. 2 times 9 is 18. And then minus 2. Oh, of course. We have a lot of positive number and very small negative number. This is not 0. Okay. Keep going. -2. So -2 cube. -2 square. -2. -2 cube is -8. 3 times -8 is -24. -2 squared is +4 times 11 is 44. -9. So 9 times -2 is -18. Okay, you see? -18 minus 2 is -20. And then minus 24 is -44. And cancel with the 44. We indeed get 0. Good. Because, oh, see, if the integer does not work, we're going to plug in fractions. We really don't want to deal with fractions. So thankfully, we find the roots x equals -2. So that means, so this is a root. That means x plus 2 is a factor. For degree 3 polynomial, you just need to find one root using the rational roots theorem. And then we can do long division or synthetic division. Well, for this problem, because it's in the form of x minus a, then we can use synthetic division. Okay, synthetic division. If it's other form, okay, for example, if you have 2x plus 5, well, long division. Okay, so for example, or x squared, 3x squared plus 11, something like that. Use long division. Okay, so it's exactly the form x minus c. As c could be positive, c could be negative. Therefore, here, you can imagine this is x minus -2. So c, the root is -2. So synthetic division, we put the root right here. And then we're looking for, oh, where's the p? So p, we want to have p of x equals x plus 2 and times something. We want to figure out what's this. So p is 3x squared cubed, 11x squared, 9x, and -2. Synthetic division, move the 3 down. 3 times -2 is -6. Put it right to the next column and add those two numbers. 11 minus 6 is 5. And then -2 times 5, put it in the next column, which is -10. 9 minus 10 is -1. -1 times -2 is 2. Put it in the next column. When you add them, you see we get 0. So remainder is 0. And that's always the case because we know x plus 2 is a factor, right? Therefore, 3, 5 minus 1 corresponds to 3x squared plus 5x minus 1. Okay. Can we factor this? I don't think so. You put 3x and x, and 1, -1, you put -1 or +1. But no matter what you put there, it won't give you 5x. So in this case, you gotta use the quadratic formula. Okay, so quadratic formula, 2a, a is 3, -b, b is 5, plus or minus b squared, 5 squared, minus 4a, which is 3, c, -1. Do you see -1 and negative cancel? So 5 squared is 25, and then add 4 times 3 is 12. So we get -5 plus or minus square root of 25 plus 12 is 37 over 6. So the roots, we have 3 roots. They are -2 and the -5 plus or minus square root of 37 over 6. All the roots have multiplicity 1. Okay, so all 3 roots have multiplicity 1. Multiplicity is the exponent, the power of the factor. Okay, so all of them has multiplicity 1. So this is problem 4. If you can understand problem 4, could you type 4 in the chat? Thank you, Lauren. Okay. Thank you for being here with me. We don't have many students. I hope more students can watch the recording even though they couldn't join us tonight. And I hope this review session is useful. Okay, here, so we want to work with the complex numbers. Okay, so complex numbers, standard form, that means we want to have real part plus the imaginary part times I. That is the standard form. Okay, so look at the first term. You see the first term is fractions. To get rid of the fractions, we need to multiply by the conjugate. So 5 plus 2i, 4 minus 3i, conjugate of the denominator. Okay, which is 4 plus 3i. So multiply by the conjugate of the denominator. And then plus, okay, multiplication, expand it. Negative 4 times 5 is negative 20, right? And then negative 4 times negative 7i is positive 28i. 2i times 5 is 10i. And then, 2i times negative 7i is negative 14i squared. But you know I squared is negative 1. Okay, so keep going. Okay, expand it, multiply out. 5 times 4 is 20. 2i times 4 is 8i. And then 5 times 3i is 15i. 2i times 3i is 6i squared. I squared is minus 1. Okay. In denominator, 4 times 4, 16. 4 times 3i, 12i. Negative 3i times 4, negative 12i. Negative 3i times 3i is negative 3 times 3, 9i squared. I squared is minus 1. Do you see the 12i and negative 12i cancel? And how about here? So negative 14 times negative 1 is actually positive 14. Okay, so this is positive 14. And when we combine with the negative 20, we get negative 6. And then 28 plus 10 is 38i. Okay. How about here? So 6 times minus 1 is negative 6. Combine with the 20, we get 14. And 8i plus 15i is 23i. And then denominator, negative 9 times negative 1 is positive 9. And 16 plus 9 is 25. Okay, split them. So 14 over 25 plus 23 over 25i minus 6 plus 38i. Combine the constants. So 14 over 25 minus 6. What's that? So here you can use your calculator, okay, to get what's this. And then 23 over 25 plus 38i. Here, use your calculator. So 14 over 25 minus 6 is, you will get negative 136 over 25. Okay, and then 23 over 25 plus 38, you get 973 over 25. Okay. Sorry. So here, use your calculator. And please keep fractions. Don't give me decimal, because decimal is not exact. So here, please have exact answers. Okay, so this is problem 5. If you can understand problem 5, plus 5. Oh, thank you, Lauren. Okay. And then here, use the given zeros to find all the zeros of the functions. So here we have the 0, 1 plus 3i. And then, because all the complex numbers, all the complex zeros, they are complex conjugates. Okay, so all the complex roots are complex conjugates. Well, that means if 1 plus 3i is a root, then the conjugate of it. Conjugate means they have the same real parts, but the imaginary parts differ by a sign, right? So this is also a root. So therefore, we know that 1 plus 3i is a root, 1 minus 3i is a root, okay? Then we have the factor x minus the root 1 plus 3i. Okay, this is a factor of the polynomial. And then the other root 1 minus 3i. So this is another factor of the polynomial. Okay, so what's that? Get rid of the parentheses. So minus 1 and then minus 3i. Here, minus 1 plus 3i. Okay. Distribute x times x squared. X times minus 1, minus x. X times 3i is 3ix. And then negative 1 times x, negative x. Negative 1 times negative 1, positive 1. Negative 1 times 3i, negative 3i. Keep going. Negative 3i times x, negative 3ix. Negative 3i times negative 1, positive 3i. Negative 3i times 3i is negative 9i squared. I squared is minus 1. So negative 9 times negative 1 is positive 9. You see all the terms with I will cancel. So 3i cancel, 3ix cancel. We get x squared minus x combine the like terms is minus 2x. And then 1 plus 9 is 10. So this means x squared minus 2x plus 10 is a factor of f of x. Okay, so therefore, how do we find the remaining 0? We can use long division. Because this is a degree 2, we cannot use synthetic division. So long division. So x cubed minus 4x squared plus 14x minus 20 divided by x squared minus 2x plus 10. Make sure you order from the highest term to the constant term. Okay, so here x times x squared, we get x cubed. Okay, x times negative 2x is negative 2x squared. X times 10 is 10x. Use the first line, subtract the second line. X cubed cancel. Negative 4x squared minus negative become plus 2x squared. We get negative 2x squared. 14x minus 10x is 4x. And then negative 20. Okay? And what multiply by x squared to get negative 2x squared? Well, negative 2. So negative 2 times x squared, negative 2x squared. Negative 2 times negative 2x is 4x. Negative 2 times 10 is negative 20. You see? the remainder is 0. That should be the case, right? Therefore, f of x is x squared minus 2x plus 10, and then times x minus 2. So the remaining 0 is x equals to 2 is a root. So we find all three roots. They are plus or minus 1 plus 3i, 1 minus 3i, and 2. So this is problem 6. If you can understand 6, could you type 6 in the chat? Thank you. Okay, keep going. Sketch the polynomial. Be sure to show x-intercept, y-intercept, and the end behavior. Okay, so we have first step, we find the x-intercept. Okay, so which means we set each factor of x equal to 0. So 3 over 7, this is just a number. This has no x inside, so we don't set it equal to 0. So we set the 7x minus 1 equal to 0. The x minus 10 equal to 0. The 2x plus 1 equal to 0. Solve for x. So 7x equals, we add 1 on both sides. X is divided by 7 on both sides. Here add 10 on both sides. Here subtract 1 on both sides, and then divided by 2. Therefore, the x-intercept, remember x-intercept are points. So 1, 7, 0. 10, 0. Minus 1/2, 0. The y-intercept is, we plug in the x is 0. Therefore, you plug in x is 0. So we have 3 over 7. 7 times 0 minus 1 to the 5th. And then x is 0. So we place x by 0. 0 minus 10 squared. 2 times 0 plus 1 cube. Minus 1 to the 5th. See, 7 times 0 is 0. 0 minus 1 is minus 1. Minus 1 to the 5th is minus 1. Minus 10 squared is 100. And then 0 times 2 is 0. Plus 1 is 1. 1 cube is 1. Therefore, you get negative 300 over 7. So our y-intercept is 0, negative 300 over 7. That's the y-intercept. How about the leading coefficient? Well, leading coefficients, you look at all the coefficient of x, multiply them. So therefore, here, 3 over 7 stay here. Let me use a different color so you can see. Let's use green, so 3 over 7. And then, you see, the coefficient of x is 7. But don't forget to the 5th. So 7 to the 5th. And then the next factor is x, so coefficient is 1. But don't forget the square. And then next factor, coefficient is 2. But don't forget the cube. Okay, typical mistake is forget about the power. Okay, and you don't need to multiply it and figure out what it is. We only care whether this is positive or negative. And you see all these numbers are positive, we multiply them, and we get positive. So we start with the right upper corner. So let's plot them. X-axis and the y-axis. So x 1 over 7. So 1 over 7. Put it here. 10. Let's put it here. Negative 1/2. Let's put it here. The scale might not be right. We just want to sketch it. We don't have to get a very precise picture, okay? And in the y-intercept, 0, negative 300 over 7. So we must pass through this point. And now we start with the right upper corner. So start here. When we touch the 10, 10 corresponds to the factor x minus 10. See? X minus 10. What a power. Power is 2, so that is even. See? Even. Bounce off. One over 7 corresponds to 7x minus 1. Do you see the power is odd? That means we cross. Okay, and don't forget we touch the y-intercept. Negative 1/2 corresponds to 2x plus 1 and cube. You see cube, that is odd, so we cross. Okay, so this is the graph. If you can understand problem 7, could you type 7 in the chat? Thank you. All right. This one. Okay, so first step, find the x-intercept. First of all, we want to factor. Okay, so factor. So 3x minus 7, and when you factor the denominator, you see that's x plus 2 and x minus 2. Yeah, but familiar with the factoring. So what are the formulas? So you have a squared minus b squared is a plus b times a minus b. A squared plus 2ab plus b squared. This is the complete square of a plus b. And if you have the middle term is negative, then this is a minus b squared. Okay, so this is how we factor it, right? Keep going. Part A, x-intercept. So set the numerator equal to 0. So numerator, which is 3x minus 7, set it equal to 0. Then we solve for x. So subtract add 7 on both sides. 3x equals 7. Both sides divided by 3. We have x is 7 over 3. So the x-intercept is a point, not a number. So 7 over 3, comma 0. Okay, that is part A. Part B, find the y-intercept. That means we plug in x as 0. So f of 0, numerator 3 times 0 minus 7. Denominator 0 squared minus 4. You see, the negative 7 over negative 4 is 7 over 4. Okay, so here we're putting in the original form. We don't plug in the factor form. So y-intercept is 0, comma 7 over 4. And then part C. Find all vertical asymptotes. So to find vertical asymptotes, we set the denominator equal to 0. Denominator, in this case, look at the factor form. So we have x plus 2, x minus 2 equal to 0. Well, so set each factor equal to 0. So x is negative 2 or x equals to 2. And then we want to check the limits. So when x goes to -2 from the right, well, -2 corresponds to the factor x plus 2. So x plus 2 goes to 0 plus. Now you plug in the factor form. 3x, x is -2, minus 7, over x plus 2 is 0 plus. And then x is -2, -2 minus 2. Okay, so here we plug in the factor form. You see the numerator is a negative number. Denominator 0 plus times negative number. You actually don't care what the number is. You only need to know whether the number is positive or negative. Here, 2 negative make it positive. Therefore, constant over 0 plus or 0 minus, we get infinity. But because 2 negatives give us positive infinity. And then when x goes to -2 to the other side, what's going to change? So x plus 2 will go to 0 minus. Therefore, it's almost the same. But, oh, by the way, let me use arrow. Okay, so y goes to. Okay, you see here, almost the same except this guy become negative. So this is still a negative number. Can I use this notation for a number? Okay, and then here is minus the number. 3 negative make it negative. So we have negative infinity. Is that okay, everybody? All right, next one, x goes to 2 from the right. This corresponds to the factor x minus 2. So when we plug in, the y goes to, look at the factored form, 3x. So 3 times 2, okay. 3 times 2 minus 7. Then over x plus 2. So 2 plus 2 times 0 plus. 3 times 2 is 6. Minus 7 is -1. 2 plus 2 is 4. Therefore, one negative give us negative infinity. And then when x goes to goes to 2 from the left, x minus 2 goes to 0 minus. So the y will go to positive infinity. Yes. Therefore, because we have infinity and minus infinity when x goes to -2 and 2, we can conclude that vertical asymptotes are x equals -2 and x equals to 2. We have 2 vertical asymptotes. Okay, and keep going. Horizontal asymptotes. Okay. What's okay. All right. So, yes, my word is slow. Give it some time. Okay, so part D. Horizontal asymptote. So we consider x goes to infinity. Then the y behaves, you look at the dominant terms. So dominant terms is the highest power term. Do you see here the dominant terms of the numerator is 3x. The dominant term of the denominator is x squared. So therefore 3x over x squared. While one copy of x cancel, we have 3 over x. When x goes to infinity, 3 over infinity, it goes to 0. And also when x goes to minus infinity, y also behaves like 3 over x and also goes to 0. Therefore, horizontal asymptote is y equals 0. Okay, with all these information, we can then draw the picture. I don't have enough space, so let me shrink these. Okay, so alright, we're ready to draw it. We have the real number line, x-axis, y-axis, x-intercept, 7 over 3, 0. So 7 over 3, 0. Oops. Okay, y-intercept, 0, 7 over 4. So 7 over 4, let's put it here. And then vertical asymptotes, 2 and negative 2. You know 2 is smaller than 7 over 3. So let's put the 2 here. We have a vertical asymptote. And negative 2, put it here. When x goes to negative 2 from the right, okay, plus means on the right. Y goes to infinity, so right and top. So put a dot there. And then when x goes to negative 2 from the left, y goes to minus infinity, so left bottom. Put a dot there. And then when x goes to 2 plus 2 from the right, y goes to minus infinity, that's the bottom. And then when x goes to 2 from the left, the y goes to infinity, that's the top. Okay. Horizontal asymptote. When x goes to infinity, y goes to 0. So 0, y equal to 0 is the x-axis. But you don't know whether we're approaching from the top or bottom, so let's put a pair of points. Also, when x goes to minus infinity, we don't know it's going to approach it from the top or bottom. Let's put a pair of points. Okay, now let's connect the points smoothly from the origin. Okay, so connect these points. And then connect this point. So it looks like the top points make more sense. Let's connect the top points. And then here, looks like the bottom point make more sense because we cannot go across. We don't have any x-intercept near there, so the bottom points make more sense. Let me make it draw it better. Oops. Oh, I don't want that. Okay. Yes. So draw this. Okay. So this is a sketch of the graph. And this is problem 8. If you can understand problem 8, could you type 8 in the chat? Thank you. Wow, okay. This is a long review session. Okay, problem 9. Okay, problem 9. So here you're gonna prepare because you don't know what parent function I'm gonna ask about. So you need to prepare for all types of the parent functions. What are they? Well, x squared. Then you have like this. It's passed through 0, 0, 1, 1, minus 1, 1, right? And 2, 4. I ran out of space. Okay. But you know the key points over there. And then what else? Okay. What else? We have the x cubed. It passed through 0, 0, 1, 1. And 2, 8. -1, -1, and -2, -8. And square root looks like that. It passed through 0, 0, 1, 1, and 4, 2. Cube root, it passed through 0, 0, 1, 1, and 8, 2, and then minus 1, minus 1, negative 8, negative 2. This cube root of x. And then here in this problem, we have exponential function. Oh, by the way, I forgot absolute value. Absolute value is the V shape. Okay. In this example, we have 2 to the x. By the way, no matter it's 2 to the x or 3 to the x or e to the x, as long as your base, okay, your base is greater than 1, then the graph will look like the same. So it passed through 0, 1, and it's an increasing function. Okay, so yeah, let me make it better. Right, so something like this. And you also have a horizontal asymptote, y equals 0. Okay. How about ln? If you have like log x or ln x, then the parent function will look like that. It passed through 0, 1, and with the vertical asymptote is x equal to 0. So you need to be familiar with all these parent functions because you don't know which one I'm going to ask in the final exam. Okay, be prepared for all of these types. Okay, so here, what are the transformations? Well, as we call transformations, we first do shift left or right. Okay, and so left is x plus c, right is x minus c. And then second, reflections over the y-axis. Well then, that means you have your x change to negative x. So you have a minus sign in front of x. And then the third step, we have reflection over the x-axis. Then you will have a minus sign in front of the y. And also we have vertical stretch. Then you have y will change to a number times y. Finally, shift up or down. Okay. And that's why here. Do you see x? Whoa, x plus 5. Plus 5 is shift to the left. So shift left 5 units. Okay, which means what are the key points? They are like this one 0, 1. 1, 2, 3, 4, 5. Right here. So 1, 2, 3, 4, 5. Negative 5, 1. Okay, it shifts here. But then everything else remain the same. So we still have the same horizontal asymptotes. Okay? And then next, do we have reflection over the y-axis? Do you see a minus sign in front of the x? No, we don't see it. Okay? And then, okay, next one, the third one. Do we have reflection over the x-axis? Do you see a minus sign in front of the function? Yes, we do. So negative 2x plus 5. So this is a reflection over the x-axis. So which means this point minus 5, 1 become minus 5, negative 1. Okay. Let me put a minus 5 here so I can use here for the negative 1. And then, so reflection, it'll look like that. So let me make it better. Okay. I need to pass through that point. Try again. Okay, and we still have the same horizontal asymptotes. Okay, and then keep going. Do we have vertical stretch? Yes. You see the 4 there? So y equals -4 times 2x plus 5. So vertical stretch by a factor of 4. So that means, okay, this point, we keep the x be the same. So x is the same. The y coordinates multiplied by 4. Therefore, that point was -5, -1. Okay, -5, -1. It changed to the x remain the same, but the y multiplied by 4. So -5, -4. So -5, -4. So it changed to this point. And then everything else remain the same. So we still have the horizontal asymptotes is y equal to 0. Finally, what do we have? Shift up or down? See? F3, so shift up. So shift up 3 units. Okay, so then the -4 now is become -1. So -5, -1. And then the horizontal asymptote also shifts 3 units. Therefore, it's now at y equals 3. And then keep the shape. So our horizontal asymptotes is y equals 3. Okay. Domain. See, it goes to the left forever, goes to the right forever. So -infinity to infinity. Range. We get up to the 3, but we never touch the 3. So parentheses. Asymptote. We have horizontal asymptote. That is y equals 3 and no vertical asymptotes. So here we finish this example. And so you can make up other problems to practice. Your parent functions, one of those types, and you don't know which one I'm going to ask you on the final. So be prepared for all of different parent functions. Okay, if you can understand problem 9, could you type 9 in the chat? Okay, good. We're done with the algebra. Trigonometry now. Wow, this is wow. Okay, we might go over 10 p.m. Okay, I just keep going. Okay, because I really hope you guys can do well on the final exams. Make sure you understand every problem on the practice exams. Yes, okay. Find the radian measure of the central angle of the circle of radius 6 centimeters that the intercepts an arc of length 32 centimeters. Okay, length. Well, remember the formula. Length S equals theta times R. In this case, we know the length is 32 and we know the R is 6. Therefore, theta divided by 6 on both sides. Theta is 32 over 6. And common factor is 2. So 32 divided by 2 is 16. So 16 over 3. That is the theta. And this is not degree. This is radian. Okay, so usually ratio of length would give us radian. Okay. And what is the area of the regions of the sector? So area of sector, 1/2 theta r squared. So length is this, area is this. All these formulas you need to memorize. So in our case, Theta is 16 over 3. R is 6. So R squared, 6 squared. So, oh, you see 2 and 3, 2 times 3 is 6. That cancel one copy of the 6. We get 16 times 6, which is 96. Okay, so the area is 96. And the units will be centimeter square. Okay, so that is the area. If you can understand problem 10, could you type 10 in the chat? Awesome. Okay, so here, sketch a graph of a trig functions. So you're gonna be prepared because you don't know which one I'm gonna ask you. So be prepared for all the 6 trig functions. Well, in this case, our formula will be very useful. So make sure you can memorize all those basic trig graphs. So yeah, all these basic trig graphs. So I will print this out for you on the final, but you need to be familiar with all the trig graphs. Okay? So that's why here we are looking for what? Secant. Secant. This one. The blue ones. So the angles we look at is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so draw the table. We have x, and the theta here is 3x minus pi, and secant theta. And then our y, see, our y is 2 secant theta plus 5. Our theta, 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's the first step. Second step, secant. See, secant. 1 undefined minus 1 undefined 1. Okay. And if you have trouble memorizing these, check out the recording. So there's one day, one lecture, I taught you like what are the tips to memorize those. Okay, and then the third step, figure out the x. So we know theta equals 3x minus pi, and then we add pi on both sides. 3x is theta plus pi, divided by 3 on both sides. So we have x is theta plus pi over 3. Plug in different theta. So theta is 0. Therefore, x is 0 plus pi over 3 is pi over 3. And then here, pi over 2 plus pi over 3. Pi over 2 plus pi is 3 pi over 2. Divided by 3 is pi over 2. And then pi plus pi over 3 is 2 pi over 3. And then here, 3 pi over 2 plus pi over 3 is 5 pi over 2 over 3, 5 pi over 6. And then next one, 2 pi plus pi over 3 is 3 pi over 3, which is pi. Okay, so these are the x values, the y values. So y equals 2 times secant. So 2 times 1 plus 5 is 7. Undefined, you put undefined is undefined. Here, 2 times negative 1 plus 5 is 3. Plugging undefined is undefined. Plugging 1 is 7. See, it's the same thing as this. Okay. Step 5, we can draw the graph. Let me make this smaller. I draw it too big. Okay, so make it smaller. And let's draw it. Okay. Okay. So this is set 1, 2, 3, 4, and now 5. Draw it. Okay, so here 0, x, y. At most pi, so put the pi here. This is midpoint pi over 2, and then here you have pi over 3, and then here 2 pi over 3, and then here 5 pi over 6. Okay, yep. Let's put the point. When x is pi over 3, we get 7. So 7 right here. And then pi over 2, undefined. Draw a dashed line. 2 pi over 3, 3. So 3 here. 5 pi over 6, undefined. At pi is 7. Okay, now start. The top point is always up. The bottom point is always down. Okay, so up, down, up, down, up, down. So if you imagine, keep going, imagine we keep going, and then imagine we keep going. So you want to draw 2 full period. This is 2 full period. And what is the period? For secant, period is 2 pi, and then over the coefficient of x, which is 3, okay, which is 3. So 2 pi over 3 is the period. So you'll be prepared for drawing all 6 trig graphs, because you don't know which one I'm going to ask you on the final exam. Okay, so that's problem number 11. If you can understand 11, could you type 11 in the chat? Thank you. Okay, so problem 12 is word problems. Okay, here I give you some examples, but I don't guarantee the final exam we have the identical word problems. Okay, so I just give you some examples so you can practice. Okay, look at the first one. A park ranger at point A observed a fire in the direction north 25 degrees west. So north is up, east is to the right. So let's say A is right here. Fire, so north is the top one. Okay, let me make it better. 25 degrees east. Okay, so this is 25 degrees east. And then another ranger at point B, 5 miles due east of, so 5 miles. And then, oh, we see this is north, 56 degrees due west. And then determine the distance from point B to the fire. So we want to find the side BC. Okay, so this is a solve triangle, oblique triangles, law of sine, law of cosine. Which one we use? Let's figure that out. So first of all, let's see what is this angle. That's 90 degrees minus 25 is, what is that? 65 degrees. So this is 65 degrees. And here, 90 degrees minus 56 degree is 34 degrees. So this is 34 degrees. Okay, everybody? All right. So we are looking for, let's give it some name. So opposite to angle A, call it A. Opposite to angle B, call it B. Opposite to angle C, call it C. So what do we know? We know angle A, angle B, and then we can find C, right? Angle C is 180 minus angle A. Angle A. By the way, sometimes we use this notation, angle C. Sometimes I just use C to denote the angle. They mean the same thing, right? Okay, maybe let me keep the notation that I've been using. I only use the C for the angle. Okay, so 180 degree minus angle A is 65 degree minus angle B is 34 degree. What is that? So you can plug this in your calculator. You get this is 81 degree. All right. So we know angle C is 81 degree. See, we know angle C, we know side C, we know angle A, we're looking for side A. Great. That is exactly the law of sine. Okay, so sine A over A is sine C over C. Oh, we don't care about B, angle B and side B. We're not looking for those. Okay, so plug in angle A, 65 degree. Side A is what we're looking for. Angle C is 81 degree. Side C is 5. Cross multiply. A sine 81 equals 5 times sine 65 degree. So A is both sides divided by sine 81 degree. So you use 5 times sine 65 degree over sine 81 degree. And you get, let's keep 3 decimal places. So 4.588 miles. Okay, so this is a distance from point B to the fire. So far so good. If you can understand this part, could you type 1 in the chat? Oh, 12 works, yeah. Thank you. Okay, so keep going. The angle of elevation of a kite like that, true, right? It's flying on the sky. Angle, so you were standing right here. The angle of elevation is 37 degrees. Find the height of the kite. So we want to find the h if the string is 300 yards long. So this is 300. Assuming no sec in the string. All right. You see this is a right angle triangle. And we're looking for the h, that is the opposite. For the 300 is the hypotenuse. You know, opposite and hypotenuse, which trig functions we want to use it to relate it, is sine, right? Sine is 37 degree is opposite over hypotenuse. Opposite is h, hypotenuse is 300. Therefore, h equals sine 37 degree times 300. And then you can plug in your calculator. That is 180.54 yards. Okay. So if I forget to ask you to put how many decimal places I want, I try to put as more. Okay, so try to put more as you can. Maybe 3 decimal places. Okay, usually 3 decimal places, but the final steps you have like 3 decimal places, but the intermediate steps you want to keep more digits so then your final answer will be more accurate. Okay, it doesn't hurt to keep more decimal places. Okay, so that is problem 12. So you have a word problems, but which type We don't know. Okay, I will tell you, but be prepared for all the word problems. Okay, so it is known that sine alpha is negative 5 over 6, and alpha is from pi to 3 pi over 4, which means that is in quadrant 3. And sine beta is 3 over 8, with beta is from pi over 2 to pi. That's quadrant 2. Find the exact values of sine alpha minus beta and cosine alpha plus beta. All right. So this one, you need to find what is cosine alpha. See, what's cosine alpha? You know, sine squared plus cosine squared equals 1. So sine squared plus cosine squared equals 1. So cosine alpha is plus or minus square root of 1 minus sine alpha squared, which is plus or minus sine alpha squared is negative 5 over 6 squared. 1 and 5 squared, 25. Negative 1 squared become 1, but you still have a negative 1 in front. Okay, 6 squared, 36. So common denominator, 36. So 36 minus 25 is 11. So we get square root of 11 over square root of 36 is 6. Okay, but plus or minus? Well, quadrant 3. Quadrant 3, the cosine is, let's see, quadrant 3, cosine is like the x. Quadrant 3, cosine, sine, cosine, they're both negative. So we take the negative. So in quadrant 3, cosine is negative. Okay, that's why we pick cosine is square root of 11 negative over 6. Okay. How about cosine beta? Okay, so you know, we know the sine beta, so cosine beta. Let me do cosine beta square first. I don't want to keep the plus or minus square root every term. Okay, so that is 1 minus sine beta square. And sine beta is 3 over 8 square is 3 squared is 9, 8 squared is 64. So 64 minus 9 is 55, right? Okay, then cosine beta is plus or minus square root of 55 over 64. So 55 square root of 64 is 8. And which one? Quadrant 2. Okay, quadrant 2, the cosine is also, so beta is in quadrant 2. The cosine is also negative. So we pick the negative. Alright. So we first figure out sine alpha, cosine alpha, sine beta, cosine beta. And now we're ready. Has the sine alpha minus beta. Look at the formula. Oops, here. Here. Yes. I give you the formula. So sine A minus B is sine A cosine B. Sine A cosine B is like alpha, B is like beta. Minus cosine A sine B. Minus cosine A sine B. Okay, this is the formula. Sine alpha is negative 5 over 6. Cosine beta, negative root 55 over 8. Cosine alpha, negative square root of sine beta is 3/8. Okay. Negative, negative become positive. 6 times 8, 48. 5, 55. And then minus, minus become positive. 6 times 8, 48. 3 square root of 11. So, we can combine them because they have the same denominator. So this is sine alpha minus beta. Exact value. So just leave it like that. Don't need to put in your calculator. And also cosine alpha plus beta. Alpha plus beta. Right here, cosine alpha, cosine beta. Sine alpha, sine beta. Cosine alpha is, let me make it smaller, negative square root of 11/6. Cosine beta, negative square root of 55/8. Minus sine alpha, negative 5/6. Times sine beta, 3/8. Minus minus become plus. So we have square root 11 square root of 55 and 6 times 8, 48. Minus minus become plus. 5 times 3, 15/48. And you know, this is like square root 11. Square root of 55 is like square root of 11 times square root of 5. Therefore, you can combine them. You get 11 square root of 5 and plus 15. So you can show it like that. Okay, so this is problem 13. Are you okay with problem 13? Please type 13 in the chat. Thank you. So, right, keep going. Verify the following trigonometry identities. Well, express everything in terms of sine and cosine because we're more familiar with sine, cosine. So let's look at the left-hand side. Secant is 1/cosine. Tangent is sine over cosine. Oh, you see? We get 1/cosine theta minus sine square over cosine theta. We have the same denominator, 1 minus sine square. Oh, be familiar with the trig identities. 1 minus sine square is cosine square. Oh, cancel cosine theta, which is the right-hand side. So you kind of express everything in terms of sine and cosine and then use the trig identities to simplify it. Okay, so if you can understand problem 14, could you type 14 in the chat? Thank you. Okay, so keep going. Okay, so here, yes, determine whether the given information results in one triangle, two triangles, or no triangles at all. Solve each triangles that result. Okay, so we have C is an obtuse. So C is an obtuse angle, 113 degree. B is 41 degree. And let's call this A. C is 15. Okay, so this small b is small a. We know angle C and side C, and we know angle B. Then use law of sine. Okay. Yes, so use law of sine. This is angle, side. Okay, so when do we use law of sine? When you have angle, side, or side, angle. When do you use law of cosine? Side, angle, side, and side. By the way, you use law of cosine. It doesn't mean that you don't use law of sine. Because maybe you also need law of sine, like today's class. Those two examples, we use both. Okay. But angle, side, and side, angle, you only use law of sine. You don't need to use law of cosine. Okay, so that's why here sine A over A is sine B over B equals sine C over C. We can find angle A, that's easy. That's 180 degree minus angle B, 41 degree, minus angle C, 113 degree. And that equals, use your calculator, you get this is 26 degree. Plug in angle A, 26 degree. A, we don't know yet. Angle B, 41 degree. Side B, we don't know yet. Angle C, 113 degree. Side C, 15. Okay, let's find A. So find A, we look at this one and this one. Cross multiply. A sine 113 degree equals 15 times sine 26 degree. To find A, divided by sine 113 degree. So you can put this in your calculator. Give me 3 decimal places. You get 7.143. Okay, and then to find side B, we look at these two. Cross multiply. No, sorry, I boxed the wrong one. These two. Cross multiply. B times sine 113 degree equals 15 times sine 41 degree. So both sides divided by sine 113 degree. And then you put that in your calculator. You get 10.691. So please practice using your calculator to make sure you can get the same answers. Okay, so this is part A. Part B, find the area of the above angle. Okay, so because we already know all the sides and all the angles, we can use the formula. Area is 1/2 AB sine C. Okay, you can use this formula. So 1/2 A is what? 7.143. B is 10.691. Sine C, angle C, 113 degrees. Put this in your calculator and give me 3 decimal places. You get 35.149. So this is the area. Okay, and you use it if you know side, angle, side. But because part A we already solved all the angles and sides, so that's why you can, yeah. Even though we start with SAAS, but you solve all the side and angles, and that's why you can use this formula. Okay. All right, keep going. How about here? So this is side. Side must be law of cosine. So let's see. A, B, C. So, okay. Here, B is the longest. A is second longest. C is the shortest. So this is angle B and C and A. You see, angle B, largest angle. So when we do the law of cosine, find the angle B first. So we have law of cosine here. Find the angle B. Cosine B is A squared plus C squared minus B squared over 2AC. Okay, so always find the largest angle first. Okay, because it could be obtuse, it could be acute. All right, so A is 7.6, C is 5.3, B is 9.2, 2A is 7.6, C is 5.3. Okay, so plot this in your calculator. All right, and then you get, this is approximately equals to 0.01502. And then B is a cosine of this number. You get 89.139 degrees. You see, this is a acute angle. All right. And then keep going. So once we know one angle, we can then use law of sine to find another angle, like today's class we talk about. Okay, now law of sine to find, let's say, angle A. So sine A over A is sine B over B. Angle A we don't know, we're looking for A. Side A, 7.6. Angle B, we find that is 9.139 degrees. Side B, 9.2. Okay, so how to find sine A? Let me shift this to the left. Okay. So we get sine A equals cross multiply. Okay, so 9.2 times sine A is 7.6 times sine 89.139 degrees. Both sides divided by 9.2. So sine A is approximately equals to 0.8260. Maybe keep one more digits. When I calculated, I didn't keep 5 digits. It's better to keep more digits. And then when you do sine, you get 55.689 degrees. That's the angle A. Okay, so therefore angle C is 180 degrees minus angle B. Minus angle A. And therefore we get, so put that in your calculator, 35.171 degrees. Okay. So yes, so we solved the triangles. Now how to find the area of the upper triangle? You can use, because after we solve all the sides and all the angle, you can use the formula again, A, B, sine, C. Or this problem, because we given all the sides, therefore you can also use the we talk about the formula when you know all the three sides. And that is, yes, this formula. So you can choose to use this formula, Heron's formula for the area of triangle. Or you can just use 1/2 AB sine C. So you have the same answer for the area, no matter what method you use. So, okay, A is what? 7.6, 1/2 times 7.6. B is 9.2 times sine C. C is 35.171 degrees. So put that in your calculator. You get 20.138. Okay, so that is the area. Okay. All right. That's problem 15. If you can understand problem 15, could you type 15 in the chat? Good. Okay. So yeah, we take more than 2 hours for the review sessions. Okay. This one, see? Change sine square. We can change the sine square to cosine square. That's the trick. 1 minus cosine square equals 2 cosine theta plus 2. By the way, the final exam might not be exactly this type. Okay? So in that sessions, 7.5, we learn all different types of examples of equations involving trig functions. Okay, so prepare to know all those different types. Okay, this type is just one of them. Okay, so in this case, let's move all the terms to the right hand side. So, which means we subtract 1 on both sides. We add cosine square on both sides. Then we get cosine square plus 2 cosine theta. And then minus 2 plus 1 is 1. So we get a quadratic equation. And in this case, oh, if you can recognize, this is actually a complete square. Because a plus b squared is a squared plus 2ab plus b squared. So this is like a squared plus 2a plus b. B is 1. Yeah, therefore this is a complete square. Therefore cosine theta plus 1 is 0. Cosine theta equals -1. Cosine looks like that. When do we have -1? Woohoo! That is when theta is pi. But cosine is 2 pi periodic, so you add 2k pi, where k is an integer. Okay, everybody? All right. So keep going. Vectors. So today we just introduced the definition of vectors. It has magnitudes and directions, and it has the components. We have the x component and the y component, right? So therefore, Friday we'll talk about these more. So, but right now, I just solved the problem. But Friday we'll talk about more in details. So right now I solved the problems, and if you don't understand at this moment, then after we finish our lecture on Friday, you can re-watch this recording. Okay, then maybe you can understand it better. Okay. So first of all, compute 7u minus 2v. So 7u, u is 2, 3. Minus 2v, v is 5, -4. When we do the vector operations, the constant scalar multiplied by a vector is we multiply all the components by that number. So that means 7 times 2 and 7 times 3. Okay, so then here, negative 2 times 5 and 2 times -4. Therefore, and when we do the additional subtractions, we calculate component-wise. So 7 times 2 is 14. That's the first coordinate. And minus 2 times 5 is 10. Okay, so you do the first coordinate operations. And then you do the second coordinate. 7 times 3 is 21. And then minus 2 times -4 is -8. Therefore, 14 minus 10 is 4. 21 minus negative become plus. 21 plus 8 is 29. So this is the vector. Okay, and then when we talk about the magnitude of it, it's the square root of each component square. Add them up. Plug this in your calculator. 4 square plus 29 square is 857. And you can leave your answer like that. You don't have to compute into the decimals. You can leave it like that. This answer is exact. Okay, so this is part A. Part B, find the angle between U and V. We will talk about that on Friday. Okay, so but we follow this formula. This is the angle. Okay, so yeah. So maybe on Friday after the lecture you will understand more. Okay, so use the formula. Cosine theta is u dot v over the magnitude of u times the magnitude of v. Okay, this is dot product, and we'll talk about that on Friday. Okay, so but right now I'm just keep solving the problems after the Friday lecture. You can come back and watch the video, okay, recording. So UV, so U is 2, 3. Dot product V is 5, -4. Dot product means first component multiply. So 2 times 5 add second component multiply. 3 times -4. So this is how we compute dot product. Multiply the first component, okay, and then plus you multiply the second component. 2 times 5 is 10. 3 times -4 is -12. So the answer is 2. Alright. Then the magnitude of U is, so U is 2, 3. So magnitude, each component square. Take the square root. So 2 square is 4, 3 square is 9. So we get square root of 13. Magnitude of V, the square root of, for V is 5, -4. So each component square. Add them up, take square root. 5 squared, 25. -4 squared is positive 16. So that is 41. Okay, so cosine theta, U dot V is -2. Magnitude of U, square root of 13. And magnitude of V, square root of 41. Therefore, theta is a cosine of this number. Okay, you can put this in your calculator and you get, this is 94.97 degrees. So this is how we can find the angle between two vectors. Okay, so part C, projections. Projections of U, okay, in the V directions. So the formula will be given. So this is the formula, okay? Projections of U on the vector V. So let's copy down. U dot V over magnitude of V squared. U dot V over magnitude of V squared. and times V. Okay, the formula will be given in the final exams. So just write down the formula. And we already compute u dot v, that is -2. And we already compute magnitude v, that is square root of 41, but square it. And then multiply by v. V is 5, -4. So, okay, you see, square and square root cancel. We get -2/41 times 5, -4. Well, that means multiply them. Okay, 5 times 2 is 10. So -10/41. -2 times -4 is 8. So 8/41. So this is the projection of u onto v. And then, yes, we finish all kinds of problems in the practice final exams. Here, these are more exercise about the trick equations. So I will let you to read the solutions of the practice exams. So the practice exams, I went over how to solve these. Okay, so we did these examples. So yeah, so these examples are just study guide. It tells you like what type of problems could be on the final exams. Okay, and then you can like practice more problems of the similar kind. Okay, all right. Do you have other questions? So Lauren, Jaden, Nathan, do you have more questions? You're good for now? Okay, right. Okay, so if you have questions, feel free to email me. Okay, let me stop the recording. And good luck on your final exams. Have a good night.